Have you ever wanted to learn 3D programming and build your own 3D game engine, but don't know where to begin? Well, this episode may be of interest to you. This is my creation, which I've codenamed Project Rewind. Over the last couple of months, I went from this to this. This is all custom developed, no Unity or Unreal Engine. It's been completely developed with open source tools, and I'm going to show you how it all works in today's episode. If you want to build your own game engine but aren't interested in the bloat that comes with modern engines, then stick around. Now before we begin, I do want to give credit that this inspiration came from a video series that I followed last year about building a modern Wolfenstein clone using Python. Now of course we're going to be using C++ for this, but the concepts are similar, and I will leave a link to that episode in the description below. Now when it comes to building a game engine, you first have to think about what you want it to do. And I had a list of requirements that I had in mind. My first goal is that it uses open source tools. There's no weird licensing model or anything of that nature. Second, it's developed in mind to allow me to build a boomer shooter that's along the lines of a game such as Doom or Rise of the Triad. And this is for a number of reasons. First of all, I've never built my own 3D engine before, and this is something that I've always wanted to do. And while this may look like a simple raycasting method, it's all fully 3D. Third, to facilitate building levels quickly, I'm using a 2D tile editor called Tiled. This is free and open source that allows me to build maps and add additional layers and object types. This obviously means that these levels are fairly basic, but the idea is that a level designer should be able to build these levels without needing the developer to assist. And even though this is a very simple approach, it allows us to design levels very quickly with various different object types, such as enemies, lighting, walls, ceilings, floors, and it can be customized to suit the engine's needs. And finally, it's all about having fun. As I've always said, if you want to learn about game programming, then nothing is better than doing it yourself. There's a ton of amazing resources out there to help you on your journey. There's no real right or wrong path to building your own game engine, and they can be a ton of fun, rewarding, and it's the type of thing that video game companies are looking for when they hire developers. So with all that out of the way, let's go ahead and take a closer look at how everything was built. Today's video is brought to you by NordVPN. Now listen guys, I get it, this is another VPN ad, but here's the thing. I've been a NordVPN customer for over 12 months, and let me tell you how they help me. As a game developer in the modern era, if you're making video games on consoles, you're using development kits. Now it's 2024, and dev kits need to be permanently online with an IP address that's part of an allow list. That IP address needs to be static and never change, otherwise those dev kits turn into paperweights fast. And if you work remote like I do, this can completely stop you from working. So I'm all set up here with NordVPN. I'm using a dedicated IP address with an open VPN configuration into my router, and from here I just plug all my hardware into it and set it and forget it. I never have to worry about activation again. It's magical. And of course NordVPN does all this and much more. With all this geolocation blocking nonsense, when I'm on my phone, I can use NordVPN to switch my continent to Australia and get my fix of locally streamed Australian rules football. So why not take it for a spin yourself? Go to nordvpn.com/mvg and get a 2-year plan plus 4 additional months with a huge discount. It's completely risk-free with NordVPN's 30-day money-back guarantee. Link is in the description below. Once again, that link is nordvpn.com/mvg. Now to begin, the first thing is I'm using OpenGL to build out this engine, and I'm using this because it's very easy and seamless to get things up and running quickly. But I am working on bringing this renderer to Vulkan and DirectX 12 as well. And the reason for doing this is that it does open up the possibility of console ports down the line, if that's something that we decide to do. So the first thing we do is set up an OpenGL context. We can now set up our coordinate system, our projection, and our camera. Now from here, we can easily render a simple cube like this, and this is where most 3D development begins. Now we can add texturing to each face like so. Now we can think about combining many of these cubes together to form some type of wall data or wall layout, and this is where our map editor Tiled comes into it. We can use Tiled to build out a simple scene by creating a layer called walls, and we can combine many of these cubes together. Now Tiled has its own custom format called TMX, and this data can easily be loaded in by using an open source library called TMX Lite. This is a lightweight C++14 parsing library for TMX map files, and it's very easy to use. Now from here, we can pass this level data into our level map class. And effectively what we're doing is we're storing the wall data into a C++ map collection. We can also provide an ID as to which texture each wall object will use. Now from here, our level mesh builder class will build out a single mesh containing each wall object. And because we're effectively stitching together many different cubes in one go, when we send all this information to the GPU, it'll be a single draw call. This means that it's already ahead of the game in terms of optimization. But we can take it even further. We can also remove some geometry that will never be visible. For example, the sides of the cubes that connect to each other. As you can see, we have a basic idea of how this will work. From here, we can define a location to where the player will be defined. So we can add another object type called player and position that somewhere on the level. We can determine the location of the camera based on this information. We can also enable wall collision by checking if the player is on the tile that exists in our map of walls. Now there's probably a better way to handle collision like this, but it gets the job done, at least for this iteration. We can also add a floor and ceiling layer to our tiled editor. Now at the moment, this is just a simple quad rather than a cube, but I'm going to expand on this so we can have everything defined as cubes so we can add more height to the engine. By stitching all this together, we have something that resembles an old school FPS, such as Rise of the Triad or Wolfenstein 3D. Now at this point, it may be a good time to let you guys know about RenderDoc. It's an invaluable tool for analyzing 3D scenes, especially when debugging or trying to make sense of things. If your engine is just showing a black screen, and hands up if you've been there before, by running your code under RenderDoc, you can analyze the draw calls, textures, geometry, shader pipeline. It can show you any shader issues and provide more context as to why your scene looks or doesn't look how it's supposed to. RenderDoc has saved my ass many times and I swear by it. And incidentally, you can also use RenderDoc and attach it to commercial AAA games and get a sense of how they're doing things. But let's get back to the engine itself. I didn't want to limit the engine by having ceilings. I wanted the ability to have outdoor levels as well, which means implementing a skybox. And for this, of course, we create a cube map by combining 6 textures into a single entity to represent each face of the cube. In other words, the up side, the bottom side, the left side, the right side, the forward side, and the back side. Now with this, we can encompass our scene by enlarging the cube to surround the player and scene, giving the illusion that we're in a much larger environment. So I developed a skybox class that takes in these 6 textures and applies them to each face of the cube map and render them in our scene class. And as you can see, we have our skybox, and we can also define different skyboxes and load them in as needed, so there's no limit on the amount that we can use. This also means that we can start to think about environment mapping, so we can start to reflect the skybox onto our objects in the scene. Now this is pretty common in video games known as cube map reflections, but this is an additional thing I'm going to add later. For now, I'm just pretty happy with what we have. Now a 3D engine isn't just about the graphics. For our game engine handling, we're using SDL, and I'm binding WASD and mouse look to the movement of the game. Of course, any real game will require these to be defined later on, but as you can see, our engine is now starting to take form. We can also build out levels as large or as small as we need them to be. This one here supports 64 by 64 tiles, but we can go even larger than this. I mentioned that our ceilings and floors are simple quads, and this does look a little bit weird when you're moving from an indoor section to an outdoor section, something that I do want the engine to be able to handle, so I definitely will have some updates to do later on, but overall our levels are looking pretty good. Now as you can see, this particular level looks interesting, but one of the things that you'll notice is that there is no lighting applied at all, and that can really make a big difference when it comes to your game. And having interesting and cool lighting really can set the mood for the game and the level that you're playing. And one of the things I want to do is add some light sources to our levels. And to do this, I created a point light class. And what we did in our tiled editor was add a new object layer called point lights, which allows me to define and place point lights around this particular level. Now at the moment, it's only at a X and Z coordinates. There is no height associated to those light sources. So in other words, there is no way for me to put a light source on the ground as compared to a light source on top. It's basically just going to kind of sit somewhere in the middle, but we can define this later on. But the interesting thing is, now that we can add point lights, we can build a point light class to simply iterate through all the point lights that we've found in our TMX level file and basically just position those into our world. So we can go from something like this, which as mentioned looks quite sterile, to something more along the lines of this. And as you can see, this is a complete 180. Things look a lot more moodier, they look a lot more interesting, and we can do some really interesting and clever things with lights. The lights themselves don't have to be static. They can flicker on and off to kind of simulate, light bulbs that are on the verge of burning out. We can also have different RGB values that we can define. You can see here we've got kind of blue lighting here, but we can really have different colored lights as we need to. We can also have a light source on the player itself. And right now we've only defined what we call point lights, but we can also have different type of lighting where we can have something like more of a flashlight. And this is something that you will notice in survival horror games such as Doom 3, for example, use a flashlight. There is lighting on the camera itself, and having a robust lighting system is something I definitely had in mind for this engine. This also means I want to take this further and implement a shadow system into the game and provide things like parallax or normal mapping. Now, the last thing that I built in this engine was a weapon class, and this is going to manage the weapons in the game. Right now it's quite basic, and I'm using a 2D set of sprites from a sprite sheet that I downloaded from itch.io. By the way, links to everything that I talked about are in the description below. This weapon class will cycle through its animations every time the weapon is fired, and I've wired up shooting to the left mouse button. And what it does, it goes through its sprite animation when the player shoots the weapon, and adding weapons means that we can start to think about the different types of weapons in the game. We can start to think about damage and ammo depending on the weapon type, and all this stuff has yet to be defined, but it's simple enough to add this animation in. And because we are using 2D sprites, we don't have to worry about the weapons clipping through walls, which can be an issue when building your own engine. And at this point, I'm at a bit of a juncture as to where I want this engine to go. Part of me wants to keep it mostly 2D, except for the level layout of course, and make it more of a boomer shooter with 2D billboarded enemies, objects and weapons, or perhaps introduce a combination of 3D models into the game with some 2D. But let me know what you guys think in the comments below about where you would like to see this engine go. And finally, to be clear, this engine that I'm building is currently closed source. Now, this may change and I may open up later on. I don't have any issues with making this open source and putting it on GitHub, but at this juncture, it needs more work before I can do that. Obviously, there's many more things to include, including things like sound effects, animations, some type of menu or console window, additional post-processing, shadows, particles, updates to geometry to include things like floors, stairs, different type of walls, for example, physics, the list goes on, and these will all be added as I go on, but I did want to show off some early progress of this engine. And for those that you are wondering, MVG, how did you end up learning all this stuff? Where did you build it, and what was the whole process of getting to where you are today? Well, as mentioned, there is a ton of resources out there, and I think that if you want to learn about 3D engines and basically building your own, my go-to is a website called learnopengl.com. It meticulously goes through chapter by chapter into the basics of 3D to advanced topics that are still very much useful to this day. Although it's tied to OpenGL, these concepts apply to any back-end rendering engine you prefer, and other things to look at are open source games that do all this stuff and more as well. And speaking of open source, I did mention that all the tools that I've used to build this engine are currently open source, and these assets that I've used and everything that you've seen will be linked in the description below. And finally, just as a personal thing, I am looking to build a game on this engine, and I have some ideas about what that will be. And I'm looking to commission some graphic artists, some 2D pixel artists that are, familiar with building FPS style games with billboarded sprites. And if this is something that is up your alley, or you have a portfolio of this type of work, let me know, reach out to me. I'd definitely be interested in basically working with you. This will obviously be commission based. I will definitely pay you for your time, but reach out if you are interested in basically making a game together. And as mentioned, I will post updates to this engine as I go along. This is not something that you would expect to see more than a couple of times a year. But if this is something of interest to you, keep watching this channel and keep watching the series, because I'll definitely keep updating you guys on progress of this engine. But we are going to leave it here for today's episode. Thank you so much for watching. If you liked it, please don't forget to leave me a thumbs up, and I'll catch you guys in the next episode. Bye for now.